Dr. Pippa Notten, Director and Principal Consultant at The Greenhouse, a Director of TGH ThinkSpace NPC, and an Adjunct Associate Professor at the University of Cape Town, presenting Reuse Models in Food Packaging, an example for South Africa.
Hi, good afternoon everyone, and thanks for making it through to the graveyard shift, I guess. I hope I'm not going to hit you with a really technical presentation now to put you all to sleep in this late hour. So I'm going to really try and keep it light, and I'm very happy to entertain all the technical questions that you might have afterwards. Yeah, so thank you very much, Safripol, for the invitation to speak here this afternoon about some recent projects I've been involved in that sort of touched on this reuse models, and specifically in food packaging. So I'm drawing on two studies that was actually TGH ThinkSpace, our NPC, has been involved in. The one was a meta-analysis of LCAs on food packaging. So that's the cover of the report, and invite you to go and download it. I really give you a very, very quick overview, like a sort of sneak previews of what we actually did in that report in this presentation that looked at what LCAs can tell us about alternatives to single-use plastic products. And the second study is an LCA of an in-store refill system, and that we did in collaboration with the South African Plastics Pact and with a company called Sonki, and they're the ones that design and manufacture these automated refill machines as a sort of a solution to provide low-cost and a sustainable alternative to consumers and retailers. And they were kind enough to collaborate with this project, and we tied in with some of the pilot trials they were doing to do an LCA. So backing up a bit, as you see, the common thread there was LCA, and I think it's even been mentioned already in a few of the earlier presentations, but no one actually did take a step back. I was wondering if anyone would, and define it. So it used to be fairly obscure, but I would wager now, I guess most people actually do know what LCA is. But for those that may be wondering what this acronym is that we've been throwing about, so life cycle assessment, it's a decision analysis tool, or sort of a systems analysis tool that enables decision makers to evaluate the environmental performance of a product system. So we look not at just the product, but the whole product system in terms of all the steps that go into creating that product. So all the way from raw material extraction and agricultural processes through to processing and manufacturing, retail, distribution, and all the way through to the end of life, so recycling or disposal of that product. It's a four-step process. It's got an international standard that governs it. It's republished by SABS, so it's SABS 14040 and 14044. And if you look at that, it's always given as this four-step process. The first step being goal and scope, where you sort of set up your whole study, what goes in, all of that. The next step is really the heart, where you do your modeling and you quantify all the inputs and all the outputs that go into making your product. So every step in your product and that value chain that I was talking about, you do sort of mass and energy balances around it. And then you take those inputs and outputs and you extend them into what we call impact categories. So for greenhouse gases, that's climate change. And then the fourth step that doesn't fit onto the slide is interpretation, and that sort of sits below it, where you analyze your results and you make sure they're consistent and make sense, and obviously you report them to whoever commissioned your study. Yeah, so stepping back to the meta-analysis. So meta-analysis means that this project didn't do any new research. It's basically like a big literature review, where we looked at all the LCAs that had been done on, those that we could find in the open literature on food packaging. And of course, there were very, very many, so well over 100. So we had to then find ways to kind of bring it down to a manageable number, and we eventually ended up with 33 studies against a specific set of criteria, one of the most important being that they actually had to consider an alternative. So not a deep dive into a particular LCA around a specific packaging. We wanted to look at something that looked at alternatives, preferably something like a reuse alternative, or although there was often different materials. So we broke it, and then also once we started analyzing our studies, that sort of fell out into these 3 product groups: refrigerated products, fresh produce, and pantry goods. Yeah, so very, very high level findings of the meta-analysis. So trouble with LCAs is often anyone's dealt with them too much. The answer often is depends. It really is very context dependent. So to try and get around this, what we did in this in the meta-analyses was to try and break it down into, well, if it all depends on context, then let's break down the solution, the sort of the recommendations or the findings per those contexts. So that's what we attempted to do with these matrices for the 3 different product groups that we looked at, so being refrigerated products. And as I said, I'm really going to gloss over and invite you to look at the reports to go through these in detail, because really they can be summarized in my 3 key messages over here. So essentially looking at those 3 product types, but really overarching coming out of that is wherever the food type allows it, food should be sold unpackaged or in reusable packaging, as this is almost always environmentally preferable to food in single-use packaging. But for foods with high production impact, so something like meat, dairy products, we all hear how we should be moving away from a meat-based diet because it's very impact-intensive. So for products like that, packaging design should prioritize minimizing food waste. So it's really for products with very high production impacts, it's actually about the product and getting that product to the consumer and making sure it actually gets consumed than it is actually about the packaging. But of course, when do you know whether you're in 1, avoid packaging or minimize packaging, or when do you know when you're in 2, which is packaging doesn't matter, actually it's the food product and protecting it that's important. So we found, really you need studies in many cases that cover the full value chain. Really important to look at your full value chain, and especially to include the product losses, so include the product itself. And many packaging LCAs are not good at doing that. So, we did find a good number, because otherwise we wouldn't have been able to draw those conclusions. But by and large, too many LCAs still just look at the packaging, and they're not looking at the contents and the role, of course. So it's really important to have this product system view, which is what LCA, if done correctly, should bring. Correct. So now I skipped over. Yeah, so I think, so the UNEP reports were specifically with a policy recommendation focus. So the idea of the report is actually policy recommendations, and the number 1 really being that we need a level playing field for reusable packaging. And I think thanks to Graham's presentation already this morning, I think we really saw in depth the sort of the legislation that's coming in, specifically in Europe, around the need to create a level playing field with single use, whether it's stimulating recycling, but it's really much the same instruments needed for reusable packaging systems. So here, just the recommendations for reusable packaging coming out of our meta-analysis. The report is wider. It does also look at single-use packaging and has recommendations, but since my presentation this afternoon was very much focused on the reuse or reusable, I've only included those here. Again, the need to consider the whole packaging system. So with reusable systems, including the product is as important, but also very important is the reverse logistics. So when you're talking reusable, it's really important that you have the collection and any washing and maintenance and losses that go. So very much that whole product system view again. And from that, a main finding is that your washing or your distribution or your reverse logistics should be widespread. So you need to minimize those transport distances, because if you're collecting used or returnable packaging and bringing it back, if you're doing that over long distances, that's when your reusable packaging models tend to not be favorable or less favorable to the single-use ones. And that relates to that third point. So if you can encourage standardization, and again, that's coming more from the policy, and I think there's some Latin American examples here where they've done this really well, is if you have a standardized crate or bottle, then it allows more company cooperation and pooling and pooling resources really in terms of your logistics. So standardization is something for legislation there. And then the last two is, and I think I'm going to illustrate this with my case study for South Africa, is that the really important thing about reusable packaging systems is that it really does become reusable. And for that, what I mean is if you have if something's reusable and it doesn't actually get reused, it generally has a higher environmental impact or environmental footprint than a single use. And for that, it needs to be accessible and convenient. And I think for one, I'm guilty of buying the reusable cup maybe at Vida because it looked so cool, and then it goes in the cupboard and I actually don't take it back to Vida. So in that case, it would have been better to buy the single-use cup. It's got a much lower impact than a more sturdy reusable cup. So reusable packaging must be reused. But I'm hopefully going to illustrate that for you. Just another step back. I've been talking very broadly about reusable packaging models or reusable packaging without really defining exactly what I mean by that. Then this graphic might be familiar to some. It's from the Ellen MacArthur Foundation, the Rethinking Packaging report, where they break it down quite nicely into refill on the left and return on the right. Hope that wasn't me pressing the laser button. So the return being is where a business is involved. So return packaging in this definition is where you actually need, it's more expensive to set up, it's more complicated, you need reverse logistics. You might have heard of a company called Loop that's in US and in France and the UK, where you actually refilling, you returning your shampoo bottle or your back, and then they re-clean it, they refill it, and so you need significant reverse logistics to be able to do that. On the right is the simpler refill system, and that means where it's more consumer-driven, where a consumer brings their container and it gets refilled, and it doesn't require, it's generally cheaper, easier to implement. So what I'm talking about, particularly in our case study, is this refill on the go one, where it's consumer-driven rather than requiring those sort of business reverse logistics. So we were lucky enough to collaborate with, so Sonke actually won the Plastics Pact Innovation Challenge, I think, with the Marva Foundation in 2021, so which is why they were already in connection together, and then Plastics Pact put us on to sort of, while they were doing their trials, to do the LCA. And they were running 2 pilot trials, one on detergent, so actually not food, and another one on cooking oil. So in the LCAs, what we looked at was the refill system, so the nice picture of the refill machine there that was in a few spas. And we compared that against the single-use packaging available on the South African market. So detergent was great because there's quite a range of different packagings on the market that we could look at. Different materials, different packaging sizes, so it made for quite a nice detailed comparison there. The cooking oil is the cooking oil machine. There it was less diverse options. The bottles are all PET, but different sizes. So, yeah, it's really difficult to present an LCA because anyone that's done it will know there's just so much that goes into it, so many assumptions, so much data, and I really can't, go into it in a presentation like this. So, a really, really high-level view of some of the things, but you're welcome to come and talk to me and perhaps even have a view of the report. But so we looked at these two systems. What I'm doing in this presentation and what we did for the study was actually we sort of generalized it's the one was detergent, the one was cooking oil, but we actually took those results and put it into a sort of generic product, just because they used different bulk packagings, which allowed us to have a wider sort of option set in our study. So it's sort of genericized in these results. It's combining the two studies. And then the second system we're looking at is the traditionally packed. In LCA, you always have to define kind of your functional unit, which really means, so what are we comparing against? It's the per, greenhouse gases per watt. So it's per liter of detergent in this case, liter of product, sorry. And you need it as a generic amount like that so that you can compare the dispensed versus a 400 ml bottle or a 5-liter bottle. It has to put it on an equal footing, and our equal footing is a liter, mostly, although we did do sensitivity with different amounts dispensed, so a small amount or a larger amount. So the first thing we always do with an LCA is we draw up these nice system, what we call our system boundary, and we draw up in a flow diagram all the processes that we should be including, and we do our mass and energy balances around each one of them. I'm not going to go through it because it makes more sense to go through it in the results, so I'll show you that. But what we're doing there is we're deciding what should be in, what should be out, especially for the refill system. The decision was, well, should we be including the bottle? If someone brings a bottle to the refill station, should that be included in the LCA of the refill system, or should it be excluded? It can be argued both ways. The pilot trial did actually have bottles there because they were encouraging people to use the dispensing machines. So you could take a bottle and fill it. Ideally, though, what you want is for people to bring their own bottle from another product system. They bought detergent or cooking oil 3 weeks ago. They finished that, and they bring that bottle that would have been thrown away, and now they refill it. In which case, we could say then it's actually not belonging to the refill system. It's actually belonging to that previous single-use system. And then the single-use packaging, also similar, all that went into it. As I said, very high level. Inventory data we got from the pilot trials, and then for everything else, we use what's called the EcoInvent database. It's actually a Swiss database, but it's got quite a lot of global data and even some South African data. We've worked with them to put more South African data in it, and that allows you to build up, especially the comparative system. Yeah, actually, so a good disclosure, even though I had all the nice sunlight pictures there, Unilever weren't involved in the study. So we're using secondary data for the comparative system. Then the final, one of the things to decide when you're setting up your study is an impact assessment method. This is the sort of the set of impact categories. So what impacts are we looking at in the LCA? So it's as technical as it gets, but we chose a method called environmental footprint, just because it's got quite a high level of consensus. It comes out of the European Commission and their product environmental footprint project, the PEF, that you might have heard of. And it looks, just to give you, I just want to include this to give you a flavor of the kind of things that the LCA, impacts that it looks at. So it's, climate change, which we would expect, but it's also got sort of human toxicity. It's got organics, respiratory and organics. So those are things that affect human health. It's got things that affect ecosystem quality, like acidification, excess nutrients called eutrophication, and then things like water and land use and resource use. So it takes, you take all your inputs, outputs, and you bring them into those 16 impacts. Still a lot of things to try and compare against and present, certainly in a presentation like this. So what we've done is we aggregated them down. The EF is a nice method. It's one of the few that has a sort of even though it's still values-based, it provides some weights for those impacts, so that you can aggregate them and have a fewer set of things to look at one time when you're comparing, your systems, and I'll show you that now. So what we did is we aggregated them down to the 5 things on the side, which is climate change, human health, ecosystem quality, water and land use, and resources. So rather than going through, because you can imagine, this next graph, results snapshot, looks complicated enough, but if I'd included 16, it's falling off. Oh dear, and I thought we'd check the slides. Oh dear. This should have all 5 categories sitting underneath it. So what's missing is the labels at the bottom. So, oh dear, that's a bit confusing. So the first two bars are the climate change, first one for the single-use bottle and the second one for the dispensed system. And the one after that is human health, and then the tall ones are the ecosystem quality, then it's land and water use, which is the ones that are really small, so this system didn't have very big land and water use impacts, and the last one is non-renewable resources. So sorry about the corruption there. But I just wanted to kind of walk through the two bars. I know it's rather confusing, because the colors have also corrupted. Gosh, this is really crazy. So the second bar was supposed to be this dispensed with all these nice different colors to the first bar. So now this really was an impenetrable result, and now it's become like super impenetrable because it's got no axes and wrong colors. But anyway, so this first bar, I just wanted to break up the life cycle. So this, let's just look at the first two. So it's climate change, and this is the single-use packaging. So the bottom bar, the bottom color, this green one, is the bottle and cap. And then the next section up is the transit packaging. And then that blue one is the filling, labeling, and especially delivery to store, actually, is most of that impact. And then the top black bit is the impacts around managing packaging end of life, so mostly around disposal. So that's the breakdown in the life cycle for the single-use one, and then so apologies, weirdly, that the colors now don't correspond at all to the legend, but the next second bar along there is the one for the dispensed system. So if we just look at its climate change impact, the bottom one is the refill station itself. So actually really small, so that's, but that's because the refill station, it's going to last about 5 years. That was our estimate, actually, because these were pilot trials. So actually, they didn't really have any idea how long the machine was actually going to last, but we varied it from 2 years to 5 years. It also really depended on the throughput, on the sales, how much the refill machine was dispensed over its lifetime. But basically, because it's sort of quite long-lived, when you look at it per liter, the impacts of that machine is quite low. But then the next one is the delivery to store. So that's also quite a big impact. And then the one after that is the bulk packaging. So even with a dispensing system, with the refill system, you still need to get the product to the machine. So a big chunk of that is actually the bulk packaging. So, and I'm going to go into that in a subsequent figure. But that was a big share of the impact. And then in my original graph, this stands out so nicely because this top one should be shaded, so showing that it might not be there. And that's actually the bottle, like a bottle provided to dispense into. So if you include the bottle, that top, by far the biggest impact would be if you then pick up this is for, we did it for various bottles, but this one's for a 50 ml rPET bottle. So if that's part of the refill system, and it's only used once, so somebody picked up a bottle, thought, oh, look, this is a new cool innovation, and they filled up the bottle, and they took it home, and then they just threw it away like a single-use bottle. Anyway, that would be actually the biggest share of the refill system. But interestingly, the refill system still, on the whole, has lower impacts, but not very much lower at all, except if you take off that top bar, the bottle, then it becomes quite close. So that was, so if you're doing reusable systems, ideally, you want someone to bring their own container from home, and then you take off that top bar, and then the impacts are very much lower across all of the impacts that we looked at. So yeah, just trying to show that then in this picture, not worrying too much about the various different lines, but what I wanted to really show, so those are just different types of bottles that could be sitting at the refill machine, different sizes and materials. But what I wanted to show with this figure was that every time you use the bottle, so if you bring it back and refill it again, your impact falls substantially because you're looking per liter again. So this is the climate change impact. And I think the interesting thing is that it's an asymptotic relationship. So once you've used your bottle sort of 9 or 10 times, there's actually very few, not that many extra gains. But it's super important to use that bottle more than once because you're sitting really high after one use. But if you can just use it even 3 times, you've really made a big difference in that impact. And if you can, have to use it 10 times, you've positively, you've actually almost got through all the benefit that you're going to get to. So you don't have to use these things 50 times, 100 times. 10 times is actually pretty much enough. Just by way of interest there, so these lines across are then for the single-use packaged product. And wherever you're falling under the line, you have a lower impact. So the dispensing system or the refill system has a lower impact every time it's under the line. And if it's above the line, then it's got a higher impact. And I thought this was just interesting, that the smaller pack sizes are more inefficient. So this holds true also for, regardless, that's the detergent pictures that I put there, but it could be any product. It's basically a 400 ml bottle has a much higher impact than a 750. And the bulk packaged product, sort of a 5-liter HDPE jug there, actually is really competitive with the refill system. And in some cases, you've got to use your bottle a good number of times to become competitive with that more bulk packaging. Still single use, but a bigger bulk packaging versus the 400. And I think that's really the idea of this refill is in actually low-income markets where you want to buy a small quantity because that's all you can afford. If you only want to buy 400 mils or 200 mils, whatever, of detergent, you can then buy it at bulk prices, which is not something we looked at with the LCA, but you also then buy it in a much more environmentally friendly way than you do if you buy a small pack size. So I mentioned the bulk packaging being really important. So it was really nice. Across the trials, they actually had 3 different types of bulk packaging that had been looked at. It was a 25-liter drum, and then a 400-liter multi-tank, and then a 1,000-liter IBC. So interesting just to show also, and the big dots, also the big dot fell off the line, but it was showing the sort of average number of uses. So interestingly, with the 25-liter drums, they found on average only about 7.5 times they were used before, because they're quite appealing, they get stolen, they disappear, and they're fairly cheap to replace. Whereas something like an IBC, the 400, the multi-tank is more expensive, and they were finding in the trials they had lasted 12 times already. Only one had become damaged and had a life of 12, so probably longer than that, but we chose sort of 12 as the average. IBC, they hadn't used them long enough to really have a use, but we've got 20 there as a sort of the literature value. Again, it's a really high investment, a high and an expensive piece of equipment. You're going to make sure that it lasts you a good number of years, and it does really get reused. And then, yeah, I don't know if I explained that well, but the idea is, again, each time you use that bulk packaging, the impact really comes down. So, if you were supplying your machines with single-use 25-liter drums, let me show the next one, then your refill system is really not at all better than a single-use system. But as long as you use them a good number of times, it starts to come down. But again, interestingly, against that bulk 5-liter, that bottom jar there, you really need the high volume and a good number of uses of your bulk packaging before you actually have a lower impact than the single-use packaging system. So turning that around and just putting it in a different way, if those falling under the line is difficult to understand, this is showing the number of times it has to be used to what we call is break even, which means to have the same or lower impact. So this picture is for this table is for the 400-liter multi-tanks. So they actually don't need to be used a huge number of times. In fact, they can be even used only once to be better than the small pack size. But if you want to be competitive with the big break-even with the bulk packaging, they need to be used quite a good number of times, up to 12 times. But they do actually always perform better. Whereas with the drums, quite often you find the refill system, the single-use system is actually always preferred. So if you don't use them enough times, then you have instances where it never breaks even. And the single-use packaging is actually the preferred system. So if you have a badly run supply system for your refill system. So that's just for showing for the bigger pack sizes, even more times where it's preferable. So running out of time, but one more complicating factor that we looked into that really affected the performance of the refill system was delivery distance. So just here, looking at two extremes, so a sort of a local 50 k's distance, and then a rural sort of 600 kilometer delivery distance. Makes a huge difference, of course, but as does also how the volume that you're delivering. So if you're only delivering, 400 liters a month per delivery, and you deliver once a month to top up your machine, means your trucks are driving back and forth. Whereas if you can deliver 2,000 liters, so like with an IBC, and then also requires storage at that site, then you're much more efficient. And so also just to show the high, sort of a high delivery distance, inefficiently run, you're always going to be worse. Even in the small pack size, your refill system is actually not environmentally preferable. But one sort of interesting slight curveball we threw in there was looking at different contexts in terms of waste management. And as Annabelle was saying earlier, in South Africa, only 30% or 30% of households don't even have waste collection. So all the results I've been showing have been on sort of a national average for South Africa. So we took that 30%, and of the 70%, we looked at how the percentage in sanitary landfill and unmanaged landfill, and only a small percentage goes to open dumps and burning. But if you look in the rural context, where almost 90% of waste ends up in open dumps and burnt, and less than 10% is going into a formal landfill, you get a different picture, and that's that top line. So just showing there the difference, a gap. So there your refill system, even at the higher 600 kilometer delivery distance, which might be more relevant because you're delivering to those small towns where there isn't any much good recycling happening, and that packaging is really being a problem, and that's possibly where these refill systems would have a very beneficial environmental impact. So same there even with the small packaging and that worst case delivery system, there are instances in a rural context where actually that does still make sense. Yeah, so slightly over time, but thank you. Just to wrapping up, it's really, I didn't say conclusions because I think there are too many variables even to make conclusions, but we could say that if you run it well, so efficiently supplied refill system will have lower life cycle environmental impacts, especially when you look at small pack sizes, so compared to the smaller pack sizes, and when end-of-life disposal is poorly managed. So if you're comparing against in a sort of a rural context where packaging is burnt or ends in an open dump, it's not being recycled or even landing in a landfill. So it's really important to encourage customers to bring their own bottle, to make, if it's going to be reusable, it must be reusable, and you can see how much that changes the impact. It's important to use those high-volume bulk containers and also reuse them many times, and to minimize your, to make your delivery as efficient and local delivery if possible. Yeah, so thank you very much, and thanks also to my collaborators on this study.